What's up, guys? Hey, we're doing the same stuff we did yesterday, but we're gonna go backwards a bit. There's 3 problems in your homework today. I'm gonna do one real quick, real slick for you, and then we'll do one together that's a little harder, and you'll be on your way. Let's get to it. So here's what our problem says. If sine of theta equals 24 over 25, they want us to find the other 5 trig functions of theta. Notice that we don't even have a picture here, but we do know one of the trig functions. We know sine. And if you remember, sine represents the opposite over the hypotenuse. So I'm going to use that to help me get a picture down. Here's my right triangle. I'm gonna put theta in the bottom left corner. I like to do it in the same spot almost every single time. The opposite of theta over here has to be 24. The hypotenuse has to be 25. So now I can use a squared plus b squared equals c squared to figure out what the missing side is over here. Let's take care of that real quick. We've got a squared plus 24 squared equals 25 squared. We'll subtract this to both sides. 25 squared plus minus 24 squared. I'll use my calculator to help me do that. That's 49. Take the square root of both sides there. Don't need a calculator for this one. The missing side that we have is 7. So now I know that the adjacent is 7, the opposite is 24, the hypotenuse is 25. If it helps you to label those, feel free to do so. And then again, you're just watching me. You don't need to copy this down. We'll do the next example together. So now I have 6 trig functions. Let's write them down. Cool. We've got sine, cosecant. Remember, cosine goes with secant, and then we have tan going with cotangent right here. Well, dude, they gave us one right at the beginning. Let's not miss that. We know that sine is 24 over 25, which means cosecant is 25 over 24. Can I reduce those fractions? I don't believe so, but if I'm ever not sure, let's just try in the calculator. 24 over 25. Yeah, it didn't simplify or reduce at all, so I'll leave my answer just like this. Let's go to the cosine, which is the adjacent side over hypotenuse. So over here we have 7 over 25. For the secant, we'll just flip that, take the reciprocal. We got 25 over 7. And then finally, tangent is the opposite over adjacent. That's 24 over 7. If I flip that, that's 7 over 24. These fractions don't simplify or reduce, so we are done right there. Sweet and easy. Let's check out one more problem together that's a slightly harder. Get out a piece of pencil and a paper. Follow me with this one. Cool. Here we are with our second example. We have, if cosine of theta equals 7 over 10, they want us to find the other 5 trig functions of theta. So do you remember what cosine represents? Yeah, that's right. It's the adjacent over the hypotenuse. So let's draw a picture of what that could look like. Again, I'm gonna draw my triangle the same way every single time. So I'm gonna have the opposite over here. I don't know the opposite, but I do know adjacent is 7 and hypotenuse is 10. We'll use a squared plus b squared equals c squared to find the missing side. This is where the calculator is going to come in handy. We'll subtract 7 squared to both sides here. That gives us 51. Now something interesting kind of happens when you take the square root of 51. It's the same button over here. I'm hitting the green one first, and the calculator cannot simplify that anymore. Square root of 51 just equals root 51. So that's what I put here. It's just root 51, no biggie. Let's label these. Here's the adjacent side, the opposite side, and hypotenuse side. Time to list the 6 trig functions. Take your time and write these down. Cool. Let's start with what's easy. Dude, they gave us one of the 6 trig functions. We know what cosine equals. It's 7 over 10. So boom, let's write 7 over 10. That means secant, the one that pairs with it, is just the reciprocal 10 over 7. And that fraction does not simplify at all. All right, let's go over here to the sine of theta. Remember, sine is the opposite over hypotenuse. So we have here root 51 all over 10. Is it okay to have a square root in the numerator? Yeah, definitely. That's totally fine. So I can leave my answer just like this. But if I take the reciprocal and I flip it, now I have a square root in the denominator, which is not allowed. Pretty soon we're gonna learn how to do this without a calculator, but for now, you can use your calculator to help you simplify this. You might start seeing some patterns show up when you get an answer here. So this is gonna equal 10 root 51 all over 51. And for now, we can let the calculator do that work. So good idea to do the work in class when you can use these calculators. You may not have one of these at home to help you out. Let's take care of tan right here. Tan is the opposite over adjacent. So that's gonna be root 51 all over 7. Is this okay? Most definitely. I can have a square root in the numerator, just don't want one in the denominator. So when I take the reciprocal here, I'll use the calculator to help me out. We got 7 over the square root of 51. So this one equals 7 root 51 all over 51. Might notice a pattern of how this is working. Again, we're gonna learn how to do that without a calculator probably next week. So here are the examples that I would use to try and do your assignment today. And we've got 3 problems. You can find it in the Google Classroom. Good luck, guys.